Hello guys, welcome back to the channel EC TechNest. Today in the day 25 of the Verilog and digital design series, we'll be discussing about a small project that is vending machine using a finite state machine. Also, it is a very common thing in our shopping markets or metro stations to see a vending machine. Most of us know how to use it, but do not know how the tech inside it works. So this is a classic engineering problem that involves both electronics as well as mechanical components. Let us see how we can solve this problem of vending machine. We have the high level architecture. It is mainly divided into three things. The first one will be input. There are it detects the coins whether you are giving a coin of 5 rupees, 10 rupees or 20 rupees. Product selection. A sub FSM that waits for a button press. That means what type of item do you want from the vending machine? Do you want a chips? Do you want a juice? Do you want something like fruits? So this is product selection. Later, the third part is the comparator logic. What this comparator logic will do, once you have inserted the money and you have chosen your product, it checks whatever the amount you have put is lesser than or greater than the product price. So if the current credit, whatever you have in your whatever you have put in the vending machine is greater than the product price, then only it will greater than or equal to the product price, then it will give out the product. See, we'll use a Murray machine approach for clarity, where each state represents a clear phase of the transaction. Idle is a phase where you need to insert the money and start the process. Then the credit will get updated, means your amount is getting updated. It adds value inside the coin for the internal register. Next, selection phase comes where you have to choose the item of your choice. Then validate. Validation is nothing but comparing whether the your current balance should be greater than or equal to the product price. Then only it will go to the next step. The next step is dispense. Activating the motor for the specific tray. Whatever product you have chosen for that specific tray, the item will be given out. That means it will fall down. Change is returning any remaining balance. If you have put a lot more money than the actual product price, you will be returning with a change. So the first thing I'll do is I'll give 3-bit value to all my products. Maybe chips is 001, juice is 010, biscuit is 011, nuts is 100, and fruits is 101. Now the product price is 15, 25, 10, 30, 20. You can give a random price, whatever is your interest. The first thing to note here is the machine will operate in five distinct states. The first state is idle, the second one is select, the third one is dispense, and fourth one is change and refund. This is just a theory. If you want, you can read this once. What I will be doing is I'll be explaining all the five states using a state transition diagram. Now you are at idle state. That means you go to a vending machine and you start the process of inserting the coins. Now the machine checks whether the coin is greater than zero. Whatever you have put, the amount has to be greater than zero. It cannot be equal to zero, right? It is like not giving the coin itself. You will go to select state after your coin in is greater than zero. Now in the select state, you will have multiple choice. Now that if you choose a valid item is chosen, that means you have selected chips, and whatever your balance amount is there, it is greater than the product price. If you have chosen chips of 20 rupees, you should have a balance of 20 rupees or 25 rupees. So you will go to the dispense phase. During the change phase, what will happen? This 5 rupees extra what you had in the balance, that will be given as change. Another thing that can happen in a select phase is you choose a valid item, but your balance amount is lesser than the product price. So you'll again go back to idle state. Now you have put a coin in, but in the select state you feel that I don't want to eat anything from the vending machine. So you'll press the cancel button. Now you'll go back to refund stage. Refund stage, what it will do is, see, one thing you have to note, whatever is there in this like a cloud bracket or a cloud box, you need to understand that it is giving it as the output. Whatever is not, it is the condition. Here it returns the current balance. Once you have cancelled the product and you do not want to buy it, it will return your current balance. Whatever money you had put, you will get it back using the current balance. Now, once I have selected the valid stage, that means I have chosen a valid item, either a chips or something, and my balance is also greater than the product price. I will go to dispense phase. So, what will happen in this dispense phase is automatically after one clock cycle, it will decrement the inventory. Means, if I have taken chips, my inventory is something. What is inventory? First of all, inventory is what does my vending machine have? It has 10 packets of chips, 10 bottles of juice. Now it has 20 items, right? So now if I have chosen chips here, it should become 10 minus 1. That means the inventory will know that there are 9 packets of chips left. So decrements the inventory. And here, if your chips price is 20 rupees and your balance is 25 rupees, it will decrement your balance. That means 25 minus 20, you will be left with 5 rupees. Again, what happens is from you'll go to change means whatever, if your amount is left like 5 rupees is your balance, right? You need to get it back. Here the outputs will change and resets the current balance. It will go back to idle state. Now again, if I am in idle state and the I have cancel button as well as my balance is greater than 0, I'll go again to refund, and this will again give a loop. Before selecting, only if I press the cancel button, this will happen. So I hope you have understood the state transition diagram. Let us see one more thing. How do I choose what product has to come out? I need some specific buttons, right? So this is how I do it. I have a logic path. In the select phase, I will have something called as a matrix. So I'll tell it as inventory 1, inventory 2, inventory 3, inventory 4, inventory 5. Like that, how much ever my matrix size is there, based on that, I'll dispense it. If I choose inventory 1, whatever product is there at the first inventory will get dispensed. Now, what we will do is, 1 minute, we will go and learn about how to write a Verilog code for this. Now, I am starting with my module multi-product Verilog vending machine. So, here now I have input clock and reset, and I have a 5-bit input for coin value. Then we have 3-bit select item. Select items means it will choose one of the 5 products. For here, what I have chosen is, let me see what I have chosen. See, juice, chips, biscuit, nuts, and fruit. These are my 5 items. I have chosen that. Then input cancel button, because if I need to cancel between the mid stage after selecting the product, I don't want to buy it. So that time I can use a cancel button. Then dispense. Dispenses, the product is coming out of the vending machine. Out of stock. Now that you have bought all the 10 packets of chips, it is now 0. So you need to tell your vending machine that my product is out of stock. Whenever the customer is coming back to buy the product, it will tell that the item is out of stock. How will we know out of stock? For the to know that, what I have done is, in my verification, that is my, what do we call it, test bench, I have written a certain code that will make me understand how the item can go out of stock. For as of now, we'll just discuss about this thing. Then I have output reg item is out, indicates which item is being dispensed. Then output reg is a 5-bit output for returning leftover money. Then I also have some internal registers which will track total money inserted and the price of the current selected item. Then we have inventory memory, an array of 5 slots, 1 to 5, each 4-bit wide, holds up to 15 units. This is for the inventory, how much items it can hold. As of now, I have done it only for 5, and the loop variable for initialization integer I. Now I have to declare all my, like, initialize my states: idle, select, dispense, change, and refund. I have given the binary value for this. Then I also, for state, I have given a 3-bit value. Let us see. Always at positive edge of the clock or positive at reset will begin. If reset is equal to 1, will begin, and state will be idle, current balance will be 0, dispense also will be 0, out of stock also will be 0, because we are at reset. Now once I have reset everything, I'll reset all 5 inventory slot to 10 units each. What I'm telling here is, since I have 5 items, that is chips, juice, biscuit, nuts, and fruits, I'm telling that there are 10 packets of each, or else to exactly say 10 chips, 10 juice bottle, 10 biscuit packet, 10 packets of nuts, and 10 box of fruits. This is what I'm loading the inventory. Now we'll begin with the state. First state, idle. First I have to check out of stock is equal to 0, means it will clear stock flag for new session. Now that you have filled everything out, it is not out of stock, right? Now at idle, we saw that we had to check the cancel button and current balance should be greater than 0, or then it will go to refund state. This is what I'm talking about. Let us load it. See, cancel button and balance is greater than 0, I'll go to refund state. Okay. Else if coin in is greater than 0, you'll go to the select state. Current balance will be loaded as current balance plus coin in. You have already given here current balance to be 0. So if you add coin in 5 rupees, current balance will become 5 rupees, and it will go to select state. This is my select state. Now I am in my select state. If cancel button, state will go to refund. Am I correct? If cancel button is pressed, it will go to refund. I have mentioned that also. Else if select item, it should not be equal to 3 dash b000, because I have not given that, right. My selection is 001 010 011. So if zeros, if it is not 000, I'll begin. That is what I mean to say here. Case select item. See, I have already made an input called select item. Here I'll select it. Whatever my user gives the input, based on that we'll get the particular product. Here one thing to note is error price for invalid selection. Now if I have a big vending machine, there might be empty slots, right? And sometimes the vendor might not have filled the product, so at that time it will just give a error price. That means dash 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 dash, or one fee. For here I have given it as 1111. You can give anything. Now that I am at my select state, I have to check if whatever inventory select item is greater than 0, means here I have a like increase the count to 10 units each, right? So I have to check whether this item is available or not. So inventory select item is greater than 0. Sorry, yeah, greater than 0. So even if one product is there, we'll begin. We'll check if current balance is greater than the price. If my current balance, whatever is there here, if it is greater than the price, I'll increment it. Means I'll go to the dispense state. See, if I have chosen a valid item and my current balance is greater than the product price, I'll go to dispense state. Else I'll go to idle. See, else if this is not there, not chosen, I'll go to idle state. This is the thing. Now I was here, right? Yeah. Else begin, out of stock will be raised. If I do not get the product here, out of stock will become 1. State idle. Since my product is out of stock, stay out of stock, I'll go back to idle. Now here what happens is, I have mentioned refund, dispense, then what is the other state? Change. Now I have to write the what the state will do. So in dispense, what will happen is, dispense, it will activate the motor or dispenser signal. So item, whatever item you have selected here will be out. Inventory select item will get decremented, means, so if I have chosen chips here, it was 10, right? 10 minus 1. so it will become 9. Current balance will be equal to current balance minus price. If my current balance is 25 rupees, I'll deduct it. Then whatever is left will be the change. Now, for change again, I'll write a FSM here. First, now let's just see for refund. Refund, what will happen is if change is equal to the current balance should wipe the to be exact. Let us see the refund first. So what happens in the refund? It will return your current balance and you will go to idle state. That is what they mean to say. Change is equal to current balance. See, whatever was your current balance will become the change. If it is zero, nothing can be done. It will go back to idle. Next, I am at change. When I begin with change, my turn of the dispenser signal means I have already dispensed the product, and change is equal to this current balance, and current balance should be equal to zero, and my state will go to idle. That means after giving the change, my internal balance will become zero. That means a reset has occurred. I have ended the this each module and the states, end case, and end module. This is how you will write the design part of it. Here we have inventory. We also have the possibility to add items to the inventory, and after the item has been removed, it is getting deducted. It means my Verilog code is running properly, and it is successfully working like a vending machine. Now we come to the test bench. Why do we require a test bench? Like, if now I have written the code, right, the design part, whether the design part is working properly or not, you have to check. So we'll register all the inputs. The outputs will be given in the form of wires, and I'll instantiate the multi-product vending machine. So always hashtag fly clock to the negation of clock. It means I've already spoken about this in my previous lectures where I have discussed deeply about clock generation. If you don't understand what is this, you need to go to that video. So it's a 10 nanosecond red clock because of the positive as well as the negative clock cycle. Now, initial begin dump file. Why do you require this dump file? I'll tell you. Since here I am using Aldec Rivera Pro, I will require this dump file to dump all the things into a .vcd file. This .vcd file will be used to get my waveform viewer. So this is very important. Without these two lines of code, you will not get this waveform. Let us first see how this is working. Now my clock is 0. I have begin with a fresh reset of 1. Coin in is 0, select item is 0, cancel button is also 0. Hashtag 20 is reset equal to 0. Now I am starting the vending machine. Now everything is reset, right? Reset equals 1. Now I can start the vending machine. So here I have multiple scenarios that I have designed. First one will be a successful purchase. Means I do not want to think much about anything. I'll buy. I'm going as a customer. I'll buy one product. See, I insert coin 10, 10, 10. So my total is 30 now. Select product 3 dash B 010. So what is 010 here? It is 25 rupees juice. So 30 is what I have put, and juice is 25 rupees. So my dispense, if dispense and change is equal to 5, display success, juice dispensed and 5 cents change returned. Else display failure, expected 5C change got percentage G D. Now the refund logic, to check whether I'm getting the refund properly or not, we'll test it. 1 minute. Yeah. So now I've inserted a coin of 10 rupees and I suddenly press cancel button. It will hold on for two clock cycles to ensure FSM sees it. Then if change is equal to 10, display success, 10C refunded correctly, else failure, refund mismatch. So what this code is also trying to do is it is checking whether my change is returned correctly or not, whether my machine is working properly, it is giving out the proper change to the customer. That is what it is checking. Now the last case that we have to check is the thing is, now consider I want to buy 10 packets of chips and I've already bought 10 packets of chips. I have taken it and I've gone home. Now there's another customer that wants to buy the chips. By miss, he'll not see the vending machine, he'll just see the device. He'll press the button and he will ask for chips. Now, what the code here says that it has to be out of stock. To check whether it has gone out of stock, we'll check. Testing out of stock, biscuit price 10. Repeat 10 begin, insert coin 10, select product 3-B011. It means it is running like a loop to empty the 10 biscuits. Now my attempt is to buy the 11th biscuit packet. Since it is not present, let us see what it will give. Insert coin 10, select product 3-B011. If out of stock, display success. Machine correctly flagged out of stock. Else, display failure. Machine should have been out of stock. Means here when I'm trying to buy the 11th product, the display has to show that now the chips are out of stock. Here a display will show verification complete. Here also we have multiple tasks that are helper tasks. Insert coin, input a 5-bit value. Coin in is equal to value at positive edge of the clock, and coin in is equal to 0 at positive edge of the clock. These are simple tasks that are used here. Since we are inserting the coin and selecting the product, every time instead of writing this code, here it is running a small task. Whatever the value is, like the name is there, using that name we can call the task. Now instead of writing the code to insert a coin every time, I have used task here, and I'm calling the task here insert coin, select product, so it knows what to do. Now let us check whether my verification is completed. The first scenario here was to buy a juice, right? Let us check whether we have bought the juice. Buying juice, price is rupees 25. Failure, expected 5C change, got X. Then testing a refund mid transaction. Failure, refund mismatch, got 20. Scenario 3, testing out of stock biscuit price 10. Attempting to buy the 11th biscuit. What is the output that I am getting? Machine should have been out of stock. Correct, right? Since I'm trying to buy the 11th product, the machine is out of stock. Here, let us check what has happened. If the item is dispensed and the change is equal to 5, display success juice dispensed, 5C change returned. But what is happening here? Failure, refund mismatch, got 20. Why is that happening? Let us see. We have to edit the code, right? Let us see. Where is the code? We have to go to price. Let us increase this like this. We were in refund, so we have to go to refund. Change is the current balance. What is the current balance? Current balance minus price. So once I have chosen my product, it has to reduce down to 20, right? Is that happening? No. I have chosen what is the item? Refund logic. Okay, 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 okay. Hmm. The item that I have chosen here is 3-B 010. 010 price is 25 rupees. The coins I have inserted is 30. It has to give change is equal to 5, right? Why is it not giving? Expected 5C change but got X. We have to check why have we got this X value. So we have to check the change, state change. Let us check how. Dispense is 0. Change is current balance. Okay. Here what we can do is we can put minus price. Let us check now. Our code has to work. Hope there are no errors in this. This is fine. We'll see this later. But the code has to run. Again, it is failure itself. Expected 5C change got X. Hmm. What is the price here? Price for the juice, that is 010, is 25. So it had to be 30 minus 25, right? Maybe the insert coin phase. Let us see. The current balance is not getting updated properly. Else, if coin in is greater than 0, the current balance plus coin in. Okay. It had to return it. Current balance. Hmm. Hmm. Okay. See, this part of the code is working properly where I've inserted the code and it machine should have been out of stock. Let us check the scenario to whether it is working properly. I have to tell that inventory depletion and out of stock. That is 3, okay? The 2 is this one, right? Mismatch. Here also the refund is mismatch. So the problem is with insert coin. What is coin in is the value. Okay. At positive edge of the clock, coin in is equal to 0. Hmm. It is very important to understand the code. Even I did not check it. Let us see what can be done. Current balance plus coin in. Okay. So the current balance had to get updated, right? Give me 1 minute. I'll check it. Okay, guys. The thing is, I have changed the code a bit. I have understood what was the problem. The main thing that we had made a mistake in the previous code was here when you saw the purchase phase, I was inserting money multiple times. So what happened was the first time I inserted the 10 cents, it got updated. But the next time, before I do it only, no, what happened was this design code went into the select phase. In my previous code, if coin in is greater than 0, I went to this phase. I did not update. So here what I'm adding a new line is I'm allowing to add more coins while in the selection phase. This is one main change I have made in the code. So now you might see that my output is working properly. I am buying juice 25C with 30 rupees. So the item I wanted here is the second one, 3-B010, that is juice. So item is dispense, item ID is 2, change is detected, 5 rupees. Now let's go to the test 2. What happens if I cancel or refund? Now I have inserted my money, I have pressed the cancel button. Now since I have inserted 10 rupees, I want 10 rupees, right? Wait, change is equal to 10 dollar display past 10C refunded. So my 10C is refunded here. Now the one more thing to check is out of stock. I have changed the code again here a bit. Instead of writing a big loop, what I am doing is I am telling that inventory 1 will go to 0. What is my inventory 1? That is my chips. This is my inventory 1. I am telling that this is now 0. What is 0? The stock. Whatever my stock is there, it is now 0. 1 minute. Yeah, now my stock is 0. Dot uut inventory dot 1 is equal to 0. Insert money 20. So now I've inserted 20 rupees. But the thing is, I've selected item. Now I have to show it as out of stock. Now it will check at this select item. When I press right 3-B01, it will tell that wait, out of stock is equal to 1, out of stock flag gets raised, and it will display pass out of stock correctly triggered. So my output has come properly, and all test cases have been completed successfully. You can add multiple things. So one thing I would like to tell you is when you do these type of big codes, the problem that will come with FSM is the timing. Here, when you are giving some delays, or like see the classic mistake that I made, dollar insert money. The first time it was getting updated, but the second and third time, this is like a second time, and this is the third time. What happened in this case is this money did not get updated. So you have to be very careful while writing these codes so that the design and the test bench is matching. Only when those two matches, you will get the desired output. Sometimes after you write these long codes, it will be very difficult. So my suggestion to you, whenever you're done writing the code, once check it using an AI tool. That is what I do. See, multiple times I have checked it. The thing is, when you write long codes, it becomes out of your reach to manually check it. Now that you have AI, it becomes very helpful. For the learning process, I would suggest learn it using a very practical way, that is sitting and writing down the states, understanding how it works. And for the writing of the code part, once you have written the code, if there is any error and all, you can use Gemini or any other chatbots to solve the mistakes that you have made. Since you are I was not getting output properly, I had to go to Gemini. I had to tell it what was the mistake that is coming out. I told that here my item change whatever I'm getting is not correct. So it is also confused. It took 3 to 4 rounds of testing to understand what is going on, and finally it has given me the problem. This was the mistake that I had made here, inserting money multiple times, but it was not present in my design part. I hope you'll be able to read the waveforms based on the coin in and the value that is being given. So when you go to get signals, insert money, or wait, see your current balance will get updated. Then you can also put coin in. See, coin in is not here, right? What you can do is you can tell append all. See, now from the change 2 is to 0, leave the other part of the code. From here you can observe where is my coin in. Coin in, I'm adding some value that is getting updated to the current balance. In that way you will see whatever is in your test bench, right? If whether it is getting updated or not, you can check here in this waveform. I hope you understood this project in a very simple manner. Also, the mistakes that I have made in this code, I hope you will be able to do it in a much better way. If you have any doubts, feel free to put it down in the comment section. Also, I'll be adding a link to this EDA playground. You can visit it, make changes to this code. This will be completely available on the public platform. You can change the code. Thank you, everyone.